Is it recording? Oh, it is. Okay, folks, I'm going to show you how to do some problems. These problems aren't very hard, so, well, all the mild ones are pretty easy, but the medium ones can be harder. So my document is a little bit different from yours so that I can, show you how to do the problems. But you want to do it on, a separate piece of paper, or you want to grab another piece of paper from here, right? So, anyways, let's start with problem 1A. So I'll do 1A and maybe 1C or something. Then you can do 1B. Then you can do the rest of them. Okay, so let's look at A. It's asking us to find the net force. So remember, the net force is essentially asking you to find all the forces, the sum of the forces in the x direction, and the sum of the forces in the y direction. And whatever force is left, that's your net force. Right? So for example, let's look at all the forces in the y direction. So if we look at all the forces in the y direction, we have F norm or F normal minus Fg. So in this case, right, because these two vectors are going in the opposite directions, so you have 3 newtons minus 3 newtons, so that will give you 0, right? So all the forces in the y direction is 0. Now if we look at all the forces in the x direction, you probably already know what it's going to be, but so F applied is going to be subtracted from F of friction. Right, so that's going to be 5 newtons minus 5 newtons, so that's also equal to 0. So what's the net force here? Well, the net force, F net, equals 0 newtons. Okay, just like that. Let me box it instead. Okay, so that's 1A. Now let's look at 1B. So you're looking at 1B. Now you see that clearly all the forces in the y directions are going to cancel. It's 3 and 3. But now the force in the x direction is that, right? So your F net is going to be, in this case, if you want to include the direction, we could say that this is negative 5 newtons. And that's what we get. Okay? But that's the F net in the x direction, though. So we do want to specify that, depending on what we're doing. Sometimes you don't have to specify it. Other times you do. Okay, so I want you to try C and D by yourself, which are relatively easy, I think. All right, let's pick a random problem here. Let's see. Let's do this one. Let's do number 3. So an athlete throws a heavy ball with a net force of 150 newtons. He gives the ball, this acceleration, 20.6 meters per second. What is the ball's mass? Right? Okay, so we want to know the force that is. Okay, we want to know the mass. Okay, so we have 150 newtons, and then we know that the acceleration is 20.6 meters per second squared. So so from our equation, we know F net equals m times a. So we can divide it by a, and then you get F net divided by a equals m. So that would give us our mass. Right, so all we do is 150 newtons divided by 20.6 meters per second squared. And that will give us I have to punch this in the calculator, so give me a second. 150 divided by 20.6. That gives us 7.28 kilograms. Okay, so I'm just going to write that. You can write 7 if you want. Okay, that's pretty cool. Right? Okay, so then I'll have you try number 4 and number 2. Which are basically the same problem, right? But where you just use the F net equals m times a equation, right? So this is the equation you're thinking about. Okay, so let's look at the medium questions. Okay, so let's do number 5. Number 5 is a little bit harder, I think, right? So let's take a look at this. So we have a 60 kilogram student who accelerates along a smooth, flat hallway. Okay. And this is the acceleration. So let's write down what we're given here. So it's 60 kilograms. And then the acceleration is 0.5 meters per second square. It's asking what is the net force that is acting on her. Okay, so to be able to do this problem, we need to write down our equation first, right? So we know that F net is equal to M times A. So we know exactly what M is and we know what A is. So we have F net equals 60 kilograms times 0.5 meters per second square. Right? They're just asking, right? What's the force here? So in this case, we get 30 newtons right away, right? So that's 5A. Maybe I should write it in a different color. 5A. Right, so let's look at 5B. So for 5B, find the force of friction if the coefficient of friction is this. Hint, draw a free body diagram. Okay, so remember the force of friction, right? So force friction is equal to mu times R, okay, where R is equal to Fn, the normal force. And we know that the normal force, Fn, is equal to Fg. And that comes from this, right? So here you have Fg and Fn. And they're equal to each other because it's not specific, I suppose, but it's pretty clear that the person is not jumping up and down, right? They're just moving across. Right? So here we have our F applied, or our F net, right? F applied. Okay, and then we have our force friction. And we want to know what it is. Okay, so for this problem, you have to find R first, then you multiply it by U, right, or mu, which is, right, so we know that mu is equal to 0.11. Okay, so I'm running out of space here, but, okay, so we know that Fg is equal to M times G. So let's do, M is 60, so we do 60 times 9.81 meters per second square. And we get, let me see, I had to put in the calculator, 9.81. Okay, so that is 588.6 newtons. Okay, so we get this. So now we know, right, what R is. Because we know what R is, we can multiply it, right? So all of this, right, this is going to give us that number. And then we do, okay, so now we do 0.11, right, F of F, times 588.6. So times 0.11, we get 64.7, let's say, right? So we get 64.7 newtons. That is the force of friction. Right, so we can see pretty clearly what's going on here, right? So now it's asking, okay, so now it's asking what is the applied force, right? What is the amount of force that is being used to push the student? Okay, so this is pretty interesting because we also don't know what F apply is. What is this, right? And that's what it's asking us to find now. Okay, so remember what we found was F net. Okay, so we didn't actually find F applied. Sorry if I said F applied earlier, but they're actually different. Whoops, my bad. But anyways, so for I didn't read ahead, so that's bad. So anyways, we have C. Okay, so 5C. So for this problem, what we need to do is we have to consider F net. Right, so we have F net equals, now the two forces that are involved are this one. Actually, should we make F applied positive minus F of friction? So now we do a subtraction. So F net plus F of friction equals F applied. Does that make sense? Right? So we have these three different forces. Really, they're just two, but sure, we can think of them as three. So we have 30 newtons plus 64.7 newtons. So that will give us 94.7 newtons. Right there, just like that. Right, so it's really useful to draw a free body diagram, right? Don't forget your free body diagram. It tells you what to do. Okay, so that's number 5, A, B, and C. Okay. Let's see, number 6. Okay, I don't want this video to go on too long. Number 6. Is number 6 worth doing? No, I think you can figure number 6 out. But let me write you the. Let me draw the free body diagram here for you. Okay, so we have a helicopter. Okay, and of course there's an FG on there, and then what is the lift force required? Exerted on the. Okay, so then you have F lift. Now we don't actually know how big it is, right? Because that's what it's asking you to do actually. F lift. Okay, so with this free body diagram, I think you can figure this out, right? Because then you can write F net equals F lift minus FG. And okay, and what's pretty interesting is that you can actually find F net right away, because remember F net is equal to M times A, and they gave you A here, so they're saying A is equal to 2.0 meters per second square, and it's accelerating upwards, so we're going to take that to be positive. Right, so you can find F net, so now it becomes kind of the same problem as the one above, where you have F net plus FG equals F lift. Okay, so that's the problem here. Okay, but I think the one thing I want to mention is that you want to make sure that your gravity is negative, right? Because the gravity is going downwards. So in this case, it's actually kind of like F net plus a negative G, if that makes sense, right? Because the acceleration here is positive, but then the acceleration here is negative. Right? Okay, that just made it kind of confusing. But this has positive acceleration, this one's a negative acceleration. Equals F lift. Okay, so that's it for problem 6. You could try that. Now the one that I kind of want to do for sure is how long has it been recording though? Maybe it's been like 8 minutes. Let's see, number 7. I feel like number 7 you guys can figure out how to do this one on your own, because it's basically our elevator lab, so I want you to try that. This one, number 8, is kind of interesting. Let's see, so I have time. Let me do number 9 first. So for number 9, you have FG, you got Fn, estimated mass M is in an elevator accelerating downwards. Okay, so what's interesting is that the acceleration is downwards, right? So that tells you that the acceleration is negative. Okay, so, or the acceleration for F net is negative. Is that right? Okay. So what's the reading on the force meter, right? So remember, the scale or the force meter measures Fn. Okay, so that's what it measures. So you have F net equals Fn minus Fg. So you have F net plus Fg equals Fn. And this is the key word here, negative acceleration. So you have negative m, oh, no, sorry. Whoops. So you have m times negative a plus m times g in this case. Right, so then essentially what you have is mg minus ma, which gives us Fn, like that. Okay, so that means answer is B. Okay, so it should be like that. All right, let's look at this number 8, and then I think yeah, okay, let's look at number 8. Number 8. Okay. I don't know how long I've been recording. Let's do number 8, and then I'm gonna probably stop here. Okay, so an elevator lift and its load have a total mass of this. It accelerates vertically. Okay. Oh, sorry, vertically downwards. So 0.2 meters per second. What is the tension? Okay, what's Ft? Okay, so for this problem, we have F net equals F tension minus Fg, right? You can imagine here, Fg and Ft. Right, so remember F net is equal to M times A, right? So you do M times negative 2.0 meters per second square, okay, equals Ft minus Fg. So in this case, wait, is this really it? Is this problem not that bad? I think so, yeah. So what I like to do is I actually like to write M, right, A like this, equals Ft minus Mg, right? So in this case, you have M A plus Mg equals Ft. Take out M, you have A plus G equals Ft. So in this case, M is, or given M is 750 kilograms. So you have 750 kilograms times, now remember A is negative because it's going downwards. So that's 2 plus 9.81. I guess I'm not gonna put the units in there. Too lazy. Okay, equals Ft. So that's 7.8. Okay, I'm actually gonna put the unit here. Times 750 kilograms. Our Ft is about, let me put this in a calculator. 750 times 7.8. The answer is 5,850 newtons. Okay, so these are some of the easier problems, I suppose, I'll say. The other problems do get a little bit harder, right? So especially number 13, number 12, and number 11. It would be too long for me to make this video to show you how to do all of them, but I want you to try, and I want you to not forget that there is an answer key on Schoology that I put up, and there's also, like, if you didn't see, the answers are also on the back side as well of your worksheet, but this is how you do them. Okay, so try these, and I want you to try all the medium ones. If you have not, and we're gonna do the spicy problems in class, so I will probably start working on some of these in a bit here. Okay, bye.